Hey guys, I hope you're having a great weekend. So this video is for any of the CP chemistry classes at Duluth High School for the fabulous learning earned curve opportunity. So some classes took it on last Friday. My class is going to be taking it on Monday. So if you have not taken it and you want to go over the answers for it, this video will help. Again, let me just reiterate and lovingly, strongly suggest that if you have not attempted these questions on your own, please don't just write down the answers. Try to do these questions. Try to look back at your notes or PowerPoints that have been posted. I know for sure my kids have PowerPoints posted on our e-class, and all of this information is not new information. And this is from Unit 1 on moles. So that is all on our e-class. We're going to go over this quickly. For my classes, just to let you know, try these. Listen to me, try to explain them to you. The answers are going to be in a PDF under the Content tab on Unit 1 moles. And it will be titled Answers with a copy of the PDF if you happen to have lost your copy. I cannot stress enough, if you are just pausing this video and writing down the answers, it does not, I don't wonder why you're not learning it. You have to attempt them, you have to try them, and you have to get your calculator out. You will need a pencil, periodic table, and your calculator to be able to work out these problems. These just don't come to you overnight. So make sure you're using your calculator. I know that sounds silly, but when people keep telling me, I don't get it, Miss D, and you don't even have a calculator, periodic table out, yeah, you got to have your resources to be able to achieve it. All right, so I stuck it into a Word document again so we could go over this. So that way we could talk about the questions before I just show you the answers or anything like that. So the first question reads, what's the empirical formula of a molecule containing 18.7% lithium, 16.3% carbon, and 65.0% oxygen? All right, so automatically, even though it doesn't say it, those are percents. So think about your percent composition that we talked about and learned about. We have those 5 steps that we are going to go over. So here we go for the answers of these. So remember the first step that you do, you want to take your percents to grams. And when it says empirical formula right here, what that's saying is just the smallest that those combination of elements can be divided into, which means whole numbers, whole moles, everything like that. Where in molecular are bigger. We use the example of caffeine being bigger, but for the molecule water, H2O is the smallest it can be. It's not going to be any larger than that. So that's empirical and molecular formula. So here we go. All right. So lithium, we take that 18.7% right here, and we make it into a gram. Like that is step 1, literally taking your percent to a gram. Like whatever it says, if it says 28, 18, whatever percent it says, those are the number of grams you're going to have to work with. So lithium, 18.7%, because the 18.7 grams. Same thing for your carbon, 16.3% becomes 16.3 grams. And I know this is cut off. And again, when you see the PDF with all the answers, it's all beautiful, smooth, one document, easy to read. This is just for me to talk about and go over with you verbally. So 65.0% goes straight into 65.0 grams. Now, step 2 is using your molar mass to convert it from your grams to a mole. So you're going to take, for lithium, you look at your periodic table and you see that the element lithium is 6.94 grams. And remember, that's to 1 mole. Now that is that many grams from your AMUs within 1 mole. Now, 16.3 is our given. And for carbon, we had 12.01 on the periodic table. So that's their AMUs. When you make it into molar mass, that is grams to 1 mole. So that is why moles are on top right there. For oxygen, look at your periodic table. Find oxygen. You will see that it has 16 grams AMUs. So 16 grams to every 1 mole for your molar mass conversion. So these top numbers here are the numbers when you divide. So for lithium, when you take 18.7 and you divide it by 6.94, you get 2.69. Then for carbon, you get 16.3 divided by 12.01, giving you 1.36 moles. When you take 65 and divide it by 16, you get 4.06. Now, step 3, right here. Identify who was the smallest that you got. When you compare 2.69 and you compare it to 1.36 versus 4.06, who is the smallest number? Is it the 2, the 1, or the 4? The 1.36 is the smallest. So you divide that number into each and every one of these. That is your step 3. So when you take 2.69 and divide it by 1.36, you get 1.98. Then when you take 1.36, divide by 1.36, you get 1. Then for oxygen, you take 4.06 and divide it again by 1.36, and you get 2.99. Now, your 1.98 and your 2.99 are close enough to the whole numbers that there's no need to do your step 4 and 5, where you're multiplying it by another whole number, all of them, so that they all become whole. Hypothetically, again, hypothetically, if lithium was a 1.5, he's not close enough to a whole number. So that means we would have to multiply each of these by 2 to get him to a whole number. But in this example, in your number 1 right here, you did not have to do that. Now, hold on. So when I come to my final answer, just as they are listed in your given word problem, so lithium, carbon, oxygen, lost the N there, you're going to have lithium, 2, carbon by itself because 1's already represented because the element symbol is there, so you assume there is a carbon. And then oxygen, 3. And that is the empirical formula, lithium 2, CO3. All right, next problem. Next problem, the compound benzamine has the following percent composition. So it told you the it's going to be a percent composition. And it asks, again, what is the empirical formula? Believe it or not, number 1 and number 2 are exact same processes. All right, so before we see the answers, again, step 1, you literally take the percent for those elements that are given and just make it into a gram. Take that little cute percent sign and make it to a G. So carbon, right here, is 69.4%. He becomes 69.4 grams, G. Hydrogen, 5.825% becomes 5.825 grams. Carbon is 13.21%. He becomes 13.21 grams. Nitrogen is 11.57%. He becomes 11.57 grams. So again, step 2, you are taking your grams and you're trying to figure out how many moles you have. So you are going to use your molar mass. So look at your periodic table for each individual element. And you see, when you look at the periodic table, that carbon has a 12.01 AMU. So for your molar mass, that's 12.01 grams to 1 mole. You do that for hydrogen as well. Hydrogen has a 1.01 AMU, which is grams for every 1 mole for your molar mass. Then for oxygen, you have 16 grams for every 1 mole. And then for nitrogen, it's 14.01 grams for every 1 mole. Set those up. These top numbers right here in our fractions for step 3 are the numbers that you get. When you take 69.4 and divide it by 12.01, you get 5.78. And those are going to be moles. Then you take 5.825 divided by 1.01, and you get 5.77. When you take your 13.21 divided by 16, you get a 0.83. When you take an 11.57 divided by 14.01, you get also a 0.83, which is convenient. Now, out of those 4 numbers I just listed and solved for, ask yourself, who's my smallest? That is going to be your step 3. So you're taking it and you see that 0.83 is the smallest. So divide 5.78 by 0.83 and you get 6.96. When you have 5.77 divided by 0.83, you get 6.95. When you have 0.83 divided by 0.83, you get 1. When you have 0.83 divided by 0.83, you get 1. Again, this is another problem that these are close enough, your 6.96 and your 6.95, to be close enough to be whole numbers. If they were 6.5, 6.7, 6.3, you would have to, with step 4, multiply an equal number to all 4 elements to find a whole number. But luckily, with this problem, we don't have to do that. They're close enough where that could be 7, 7, 1, 1. So when So just as they are listed in your given problem, carbon will have 7, hydrogen will have 7, oxygen represented the fact that it has its element symbol there as 1, and nitrogen as 1. You have C7H7OH as your final answer. All right. So question 3, those are pure definitions, and you guys should be able to look back at your class notes. your very, very first assignment this semester was to write out the definitions for this unit. If you did not do it, I very strongly suggest that you get on to our e-class under the content page under Unit 1 moles and look up the vocabulary definitions. My definitions I literally took from my teacher's answers that I wrote out, that molar mass in grams of 1 mole of any pure substance. All right. Then Avogadro's number, the number of 6.02 times 10 to the 23rd power, which is the number of representative particles in 1 mole. Remember that when it says representative particles, it also can mean ions, electrons, molecules, atoms, formula units. All 5 of those words fall under the category of representative particles. All right, percent composition. Percent composition, the percent of a mass of each element present in a compound. The reason why you need to know these definitions is in the word problems they are going to use. Find the molar mass. You're going to need to know Avogadro's number. Anytime you are going from a mole to a representative particle, back to a mole, anytime you're going back and forth and converge using the conversion setup to find your unknown, you will need to use Avogadro's number, 6.02 times 10 to the 23rd power. All right. Oh, present composition. Questions 1 and 2, which we just went over. That is why. All right. For number 4, here we go. Number 4 asked you to find the molar mass. You are trying to find how many grams of a given pure substance are in 1 mole. So, 4A, lithium fluoride, from the ionic section from last semester, you should have been able to write out lithium, Li, and then F for fluorine, which is fluoride when you have it in the compound. Remember that lithium fluoride has a cancel out straight positive 1, negative 1, so we don't have to do any additional work to it. So lithium, since there's just one of them, you can just write out the AMUs from the periodic table. And when you look at the periodic table, lithium has 6.94. Then for fluorine has 19. When you add them together, you get 25.94 grams per mole. All right, magnesium oxide. Remember, that's magnesium and oxygen. And we went over how to name, read, and write these out last semester. Second to the last unit, we went over covalent bonding, ionic bonding, naming, writing out the chemical formula name, all of that. So, if you are struggling with us still, I very lovingly, strongly suggest that you go back onto our YouTube page and look up the ionic and covalent naming videos within that unit and go over them. All right, so when you look at the periodic table for magnesium, magnesium has 24.31. Oxygen has 16. Again, I can just write those out straight because it's straight ratio for these ionic compounds, magnesium and oxygen. So when I add those two numbers together, just adding, I get 40.31 grams to every 1 mole. All right, iron oxide. So oxygen has a positive 2. In this case, because the Roman numerals indicate for the transition metal of iron that it has a negative 2 charge, that it is going to be able to cancel each other out. So iron has a 55.85. Oxygen is going to have a 16. And I think I reversed the charges in my head. Sorry, I'm still getting over being sick. All right, so 71.85 is your total when you add them together. Strontium hydroxide is a little harder. So OH has a -1 charge. Then SR has a +2. So when you are able to take one of strontium, which when you look at the periodic table has an 87.62, oxygen has 2 of them. Now catch that because there's a subscript on the outside of this parentheses, what that is saying and meaning that everything in this parentheses, my OH, there's going to be 2 of them every time. So there are 2 oxygen, 2 hydrogen, or hydroxide. So I have 2 here for oxygen and 2 here for hydrogen. Still, I look at my periodic table, I see that oxygen has a 16 AMU. Again, if you don't remember what AMU stands for, atomic mass unit. So 16 times 2 is 32. 1.01 times 2 is 2.02. And when you add all of these together, you get 121.64 grams per mole. Let me see if I can move this picture over. One 121.64 grams per mole. All right, number 5. Here we go. Let me just drop it down some. In this question, it asks how many grams. Okay, so the fact that it used the words how many automatically tells you what comes after those words is what you're looking for. How many grams? So this is our desired. This is what we're trying to get to. And I'm trying to make it bigger for you guys. Grams is what we're trying to find. And they're asking us are in 4.5 moles of sodium fluoride. So this right here is our given. So grams is our desired. So that he is who we are trying to get to. And moles is what we are given to start with. Now, real quick, let me take 2 seconds, have my handy board, and go over some things. I have drawn this out a few times in class, and I have gotten you guys to written this down, and we have gone over and over and over it. So I just want to reiterate it one more time. All right, hope you guys can see it. Mass to mole to representative particles. Boom. All right. These have been the 2 major conversions that we have talked about within Unit 1. We've talked about how we can take mole to one of the representative particles, ions, molecules, atoms, any of those. And we have talked about mass, which we use grams. Okay. So anytime we start with our given, the thing that are told that we have is a mole. Anytime we start, when we're converting between the two of these, we end up with our conversion multiplying every single time. Whenever we convert from moles to a gram, we multiply. Anytime we go from a mole to a representative particle, we multiply. All right, then whenever we go from a mass to a mole, we end up dividing. Anytime we go from a representative particle to a mole, we end up dividing. Now, the major two difference of what I'm multiplying and what I'm dividing it by is this. Whenever you are converting from mass to mole, mole to mass, you are going to have to first find and use molar mass, which we just went over on the question above. That is question number 4. Ask in which we use the periodic table and we found each of those compounds, those chemical formulas, each of their individual molar mass by looking at the periodic table. So anytime you are going from mass to mole, mole to mass, you first find the molar mass and you use it. So anytime I have a given mole, I take my given and I have to multiply it by the chemical formula's molar mass. Or if I was given a particular gram for a particular compound chemical formula, I can take my given gram and divide by the molar mass of my chemical formula and find the number of moles I have. Now, on the other side of the chart, you have a mole to representative particle to mole. This is where Avogadro's number comes in. He is the only number. He is a set number. You don't have to find a number. You don't have to do anything about calculating other than knowing that 6.02 times 10 to the 23rd, that's a really bad 23rd, you use Avogadro's number, okay? So if I had a mole and I was trying to find an atom, I would take my number of moles and multiply it by, because I'm going this way on the chart, by 6.02 times 10 to the 23rd power to get the number of atoms. All right, for representative particles, if I told you I had 52 times 10 to the 24th power molecules, and I wanted to figure out how many moles I had of that, all I would have to do is divide my given molecule number, my representative particles, by 6.02 times 10 to the 23rd, and I would have my moles. There are 2 cycles, 2 conversion processes that we do. Mass to moles, mole to mass, you have to use the molar mass. Moles to representative particles to moles, you use Avogadro's number. Okay. So, how many grams are in 4.5 moles? So, they are telling me I have moles and I need to get to grams. Well, that would be this guy, moles to grams. So I would need to find my molar mass. I see that it's sodium fluoride. So right here, first thing I did, took my sodium, my fluoride, I was able to add by looking at the periodic table and seeing the AMUs. I took 22.99 plus 19 giving me 41.99 grams over moles. So that was the first thing I did. I found my molar mass of sodium fluoride. Now I can set up my T-chart. I put my given in the first block here, always and forever, amen. That is how that happens. You always have to put your given up top here, up top on the left. Then I took my 4.50 moles. Because moles unit is right here, when I set it up, the opposite square has to have the same unit to cancel him out. You can't have moles on top because they don't cancel. They would multiply and you have moles square. So in order to convert it, to change it to moles to a gram, you have to have moles, the unit moles, on the opposite square. So you take 4.5 times 41.99 grams, because your moles canceled out, and you end up with 188.96 grams. That is how you find how many grams you want in a given mole. Okay. Number 6, here we go. All right. So with this one, they are telling me, they're asking how many moles. So they asked me right there and then, how many moles? So he is our given. I'm sorry, not our given, our desired. Whew. Then 98.3 grams is our given, and it happens to be grams of ammonium hydroxide. And they're really sweet enough to be able to tell us that ammonium hydroxide is Al parentheses OH close parentheses 3, and that's supposed to be a little 3. So let me go ahead and fix that real quick, because yeah. All right, so when I look at this, the fact that I see the words mole and gram, I should automatically go, boom, molar mass. I need to find the molar mass. And your chemical formula is here. Aluminum, oxygen, and hydrogen. So I have 1 aluminum, so I can just write the number straight from the periodic table. That's going to be 26.98. Oxygen has a cute little subscript on the outside. This little 3 right here, that 3 means that there are 3 oxygen and 3 hydrogen. That subscript, just like in algebra, in geometry, when you are using parentheses, that 3 on the outside means that there are 3 of those each on the inside. So you have 3 oxygen, and when you look at the periodic table, oxygen has an AMU of 16. When you look at the periodic table for hydrogen, hydrogen has a 1.01 AMU. So 3 times 16 is 48. 3 times 1.01 is 3.01. When you add them all together, that is 78.01 grams to moles. This right here, what we just did, is your molar mass. So I have my molar mass of my given chemical formula. Boom, I'm ready to go. So I set up my T-chart. I put my given up top, right here, forever, ever, amen. So I was told I had 98.3 grams. So 98.3 grams go right here. And my molar mass happened to be 78.01. So because my gram unit is right here on top with my given, that means my opposite side has to have a gram. So the 78.01 is the grams to every 1 mole. So 98.3 divided by 78.01 gives me 1.26 moles. I was able to convert from grams to moles. And just like that picture I showed you, whenever I'm going from a mass, grams, to a mole, you end up dividing by the molar mass. All right. Number 7, last one, guys. Here we go. So this one's a fun one because it is just using Avogadro's number. You don't have to find molar mass. So it's asking me how many formula units. So right here, that is what my desired is. That is who I am trying to get to. That is what the purpose of this conversion is formula units. Then my given happens to be 5.0 moles of barium oxide. So the fact that it is a representative particle, I do not need to find my molar mass. I do need to know my Avogadro's number. Avogadro's number is 6.02 times 10 to the 23rd power. So, anytime I leave a mole, I end up multiplying. So, I set up my T-chart right here. My given goes up top left. My given was 5.00 moles. And because he was moles, on the opposite block, I need to have a mole down there. And I know that there are 6.02 times 10 to the 23rd formula units, Avogadro's number, which represents the representative particles, for every 1 mole. Just like there is a dozen eggs in 1 carton of eggs, there are 6.02 times 10 to the 23rd formula units for every 1 mole. If I said dozen, you would think 12. This is a set number that you just have to memorize. So, cross off my moles, boom, boom. Take 5 times 6.02 times 10 to the 23rd power, and I get 3.01 times 10 to the 24th power formula units. All right, so that's the explanations for the 7 problems that were assigned for you guys to do as review for the learning earned curve. This opportunity to get bonus points are going to be on Monday, tomorrow. You guys need to have studied this. You guys were given this on Friday. None of this is new information. So the learning curve, just a reminder, is just you being able to have an opportunity to add on, even if you got a 100 on the test, 12 more points. It's an equal opportunity for everyone to increase their learning. Please let me know. Message me if you have any more questions. Yeah, I hope you guys have a great day. Bye.